Hi third years. So in this short video we're going to recap some things that we've looked at previously as part of the physics course. In particular we're going to look at prefixes, how to convert from prefixes into standard units, significant figures, and the use of scientific notation on calculators and how to express answers in scientific notation. So we're going to start off recapping prefixes. Now prefixes are shorthand ways in which to express numbers. We don't give you the prefix value or notation in either datasheet or relationship sheet. So these are things that you have to learn and know how to use. I'm going to look at 6 of the more common types of prefixes that we use, and also the decimal and scientific notation that you'd be asked to use and understand when using these prefixes. So I'm going to start off with my first 3 prefixes. So if I start off with a lowercase n, we also then have a Greek letter mu, which is kind of like a U with a tail, and then a lowercase m. So let's see what these correspond to. So the n corresponds to the prefix nano, the mu corresponds to the prefix micro, and the lowercase m corresponds to the prefix milli. I then have 3 other prefixes we're going to look at, and we're then going to introduce these. So we've got lowercase k, a capital M, and a capital G. So again, in stating what these are, lowercase k corresponds to the prefix kilo, capital M corresponds to the prefix mega, and capital G corresponds to the prefix giga. Now these are your 6 most common prefixes that you use, not just in National 5 but also at higher level, for example. There are others that you'd be introduced to at higher level, but these are really the ones that we most commonly use. Now the reason I bunched them into 3s is because the ones at the top here correspond to prefixes for very small numbers. So it's a way in which to express very small numbers. And the ones at the bottom correspond to larger numbers. Now we can express these prefixes in terms of decimal and scientific notation. So I'm going to put a heading here, decimal and scientific. So there's 2 different ways in which we can express these prefixes. So if I start off with nano, I'm going to start here, and from the decimal point I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've divided by 10, 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So the corresponding scientific notation is 1 times 10 to the negative 9. For micro, again, starting from the decimal point, I count 1, 2, 3, 4, 5, and 6. Therefore the scientific notation is 1 times 10 to the negative 6. And the last of the small prefixes are milli. Again, starting from the decimal point, I count 1, 2, 3. So my scientific notation is 1 times 10 to the negative 3. So note, the prefixes we use generally go in bundles of 3 in terms of the powers. And the same is true for these ones here, for our larger prefixes. So for kilo, it corresponds to a 1 with 1, 2, 3 zeros. That's 1 times 10 to 3. So I think you can probably see the pattern. Mega, 1, and then 1, 2, 3, 4, 5, 6. So 1 times 10 to the power of 6. And the last one, giga, 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 1 times 10 to the power of 9. So these are our 6 most common prefixes that you have to be able to use and have to be able to make conversions from. So next we're going to look at how to convert from a prefix value into a standard unit. Okay, so now we're going to look at a couple of values that have prefixes, and we're going to convert them into standard units. And we're going to look at smaller prefixes and larger prefixes. So in particular we'll look at milli and kilo. So let's imagine we have a value, and we'll go for, nice and simple, 1 millimetre. Now what we're interested in is identifying how many metres this is equivalent to. So first of all, I'm going to consider the prefix that's been used. So that M, remember, corresponds to the prefix milli. Now milli can be expressed either as decimal or scientific notation. So as decimal it can be expressed as 0, that's 1, 2, 3, or it can be expressed as 1 times 10 to the negative 3. So we've got two different ways in which we can express 1 millimetre in terms of metres. So let's look at those two different ways to convert. So 1 millimetre equals, and if I look at the decimal notation first of all, it's 1 times 0.001 metres, which is 0.001 metres. Alternatively, I can express 1 millimetre in scientific notation. It's going to be the 1 for the 1 millimetre multiplied by the scientific notation 1 times 10 to the negative 3, which is 1 times 10 to the negative 3 metres. So I have two different ways in which to express the conversion from a millimetre into metres, into our standard unit. So now we'll look at converting from kilometres into metres. So this time round, rather than having it always been 1 millimetre or 1 kilometre, let's look at a different value. So let's put in some more numbers. So we'll go for 2.6 kilometres, and we want to know how many metres that corresponds to. So again, I go back to my table, I look at the K, that corresponds to a kilo, and a kilo can be expressed again in decimal or scientific. So in decimal it's 1,000, or 1 times 10 to the power of 3. So I can now use this to convert from kilometres into metres in one of two ways. So it's 2.6 times 1,000 metres, or 2,600 metres. Alternatively, in scientific notation, it's 2.6 times 1 times 10 to the power of 3 metres, which is 2.6 times 10 to the 3 metres. So as with previous, I have two different ways in which to take my value that has a prefix and to convert it into our standard unit. So my 2.6 kilometres, I've converted it into standard unit metres, both using decimal and or scientific notation. Okay, so now we're going to look at significant figures. Make sure we understand what significant figures are and how to express them. So we'll start off quite easy. So I'm going to write down a couple of numbers, and we're going to consider how many significant figures there are. So in this first one there is one digit, there's only one number, therefore I can say here that there is one significant figure. And significant figures is all to do with precision in which we can express values. In this one there are two values, 2 digits, therefore it's 2 significant figures. And I'm going to use abbreviation sig figs for significant figures. In this one, I've got 1, 2, 3 significant figures. Okay, so that all makes sense. The number of digits corresponds to the number of significant figures. What about if I were to this time write a value like 1.0? How many significant figures are there? Well, in the face of it, you might think that there's 1 because there's 1 value here. However, because we've expressed to the first decimal place a number as well, even though it's 0, then that's still significant. So in this case, we've actually got 2 significant figures. If we left it just as 1, it'd be 1 significant figure, but because we've added in this further bit of information, we've now got 2 significant figures. Now let's look at the other side. So this time we're going to go with 0.1. So how many significant figures are here? So you might be thinking, well, the last time round we had 1.0, so that was 2 significant figures. This time we've got 2 significant figures here. Actually, we've still only got 1 significant figure because the 0 here is not significant. It's just like a placeholder. It's just telling us the size of the number we're interested in. So now we're going to go to our next one. How many significant figures there? Well, actually, it's still just 1 significant figure because we've still only got 1 value. And if I was to repeat that, still only 1 number, still only 1 significant figure. What about if we write it this way? How many significant figures now? Well, we've not got any zeros here, so these 2 numbers are significant. So therefore we've got 2 significant figures. So why are significant figures important? Well, they're important because it shows the level of precision that you can express an answer to. And it becomes more important when we start to look at calculations in physics. So let's take an example. We're going to try and work out the distance that an object has travelled. Okay, so if I've got my distance, my speed, my time. So the distance is my unknown. My speed, I'm told, is 1.2 meters per second, and my time is 0.75 seconds. Okay, so I've got to work out what the distance is. So that's a standard 3 marker. I write my formula, I substitute my numbers in, and I get my answer. Now, let's look at this in a little bit more detail with significant figures. So, the speed has been given in 2 significant figures. The time has been given in, remember that 0 is not significant here, it's just a placeholder, so it's been given also in 2 significant figures. And my final answer, well, that's actually been expressed to 1 significant figure. Is that okay? Well, actually, yes, it is, because I could express it a couple of different ways in my final answer. So let's look what could be accepted here. So if I were to express my answer as 0.9 meters or 0.90 meters or 0.900 meters, then these would be acceptable. Or even so, I could actually express this one 0.9000 meters. Now let's look at why this is. So This one here is expressing the answer to 1, 2 significant figures. So that would be the same as the significant figures given in the question. And this is the ideal situation. So ideally, you want to express your answer to the same number of significant figures as is given in the question. Okay. This one has 1 significant figure less, which is fine. This one has 3 significant figures, which is fine, which is 1 more. And this one has 2 significant figures more. Oh, so it's 1, 2, 3, 4. So when you're expressing answers, you have ideal situation, so expressing it to the same number of significant figures as is given in the question. But you also have what's called a tolerance. So if you express your answer to 1 significant figure less, or up to 2 significant figures more, then you can still get the credit. So the credit would still be due. So let's look at this with another set of values and a slightly different calculation. So we're going to do another distance, speed, time calculation. So again, I'm going to write down what I do and don't know. So the distance again is unknown. This time round, my speed is 3.76 meters per second, and my time is 1.72 seconds. So for both of these, they're expressed to 1, 2, 3 significant figures. So that tells me a really important thing, that 1 significant figure less than that is 2, and 2 to the minus 5. So actually I can express my final answer either to 2 significant figures or up to 5 significant figures. So let's look at what the numbers do for it. So again, my formula, substitute the values in, and calculate. So this is the answer that I would get in the calculator. So let's look at the number of significant figures. 1, 2, 3, 4, 5. It's 5 significant figures, which is 2 more than given. That would still be acceptable. So if you were to leave your answer as this, you would still get full credit in this standard 3-marker problem. However, we want to try as much as possible and express it to the same number of significant figures as is given. So I'm wanting to express it to 1, 2, 3 significant figures. So I have to be careful and consider, where possible, rounding. So if I'm going to express it to 3 significant figures, my answer is going to be 6.4. The 7 here is going to cause this to round up to 7. So 6.47 meters. And that's me expressed my answer to 3 significant figures, which would be the preferred option. Okay, the final thing we're going to look at is expressing answers in scientific notation. So let's just take 2 numbers that already are expressed in scientific notation. So I'm going to take the number 1, down a little bit so you can see it, 1.23 times 10 to the power of 4, and I'm going to multiply it by 5.67 times 10 to the power of 4, and I'm wanting to look at the answer I get. Okay, so let's start off with a scientific calculator. So this is the type that most of you will have something similar to, so a Casio, generally speaking. This might be different for different calculators, but unfortunately I don't have an unlimited selection of them, so I'm going to try and show you this for the scientific calculator. So my numbers were 1.23. I'm then going to use this EXP button that allows me to then do my power of That's the power of 4. And I'm going to multiply it by 5.67 to the power of 4 equals. So I've got a whole load of numbers there. I'm going to write that down. So I've got 6, 9, 7, 4, 1, and then I've got 3 zeros. Okay. So this is where it starts to get a bit messy and where it's useful to be able to put values into scientific notation. I've got 1, 2, 3 significant figures here. 1, 2, 3 significant figures. So ideally, I want to express my final answer to 3 significant figures. I currently have 1, 2, 3, 4, 5. So you might argue, but 5, that's too many, and I would still get credit. That's true. But we want to try and be able to, for situations where we have more than that number of significant figures, to try and reduce it to the number that's expressed as part of the question. So if I go to my scientific calculator again, the way in which to do that here, well, there's a couple of different ways. If I go to this ENG button, then pressing that, it changes it into scientific notation for me. So from my calculator, I'm able to get 697.41 times 10 to the 6. That's still 5 significant figures. So I can reduce this to 697 times 10 to the 6. And unfortunately that's all the calculator will let me do. If I want to put the decimal place in here to have one number just to the left hand side of the decimal place, I can reduce it further. So it's going to be the same as 69.7 times 10 to the power of 7, which is the same as 6.97 times 10 to the power of 8. So I was able to go from this value to this value by pressing the ENG button on the scientific calculator. So that's one way to do it. Okay. Alternatively, you may be using a calculator on a phone. So let's look at what happens here. So I've got my calculator on my phone, and in order to get it to become scientific, I just turn it on its side. It makes it scientific notation. Now, your phone's going to be different from mine. This is just your stock calculator that's already installed in the phone. So if I want to do 1.23 times 10 to the 4, I'll go 1.23. I then need to go times 10, and this little x to the power of I, to the power of 4, put it in a bracket, multiplied by 5.67 times 10 to the power of 4, and I get the same answer. Now the problem we have here, on phone apps, there's no way to express that final answer in scientific notation other than you counting and working it out. So if we go back to the counting idea, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So I know that 6.9741 times 10 to the power of 8, or 6.97 times 10 to the 8, if I express it as 3 significant figures. So you can still use your scientific notation understanding and your calculator app in order to express in scientific notation. There's just not a button that will do it for you. The final type of calculator you might be using may be on your computer. So I'm going to bring one up on my